Hey everyone, really fascinating discussion today as we talk about smart grids for mesh networking and IoT at massive scale with a true innovator in this space at Wirepas. Teppo, how are you?
I'm well. Hi, Crystal. How are you?
I'm doing well. Thanks so much for joining live from Finland. So winter is upon us, both in Finland and here in Boston. So it's good to be indoors having this chat. Before we dive in, maybe introduce yourself and your journey to Wirepas, and how do you describe the vision, the mission at Wirepas these days?
Sure. So yes, I've been in this wireless and connectivity space since mid '90s, so quite long. I started my career in Nokia, where I was in design of microchips, semiconductor design side. Spent there for 13 years. Had a privilege to be doing a lot of industry first stuff, like very first 3G edge modem in the world
Mm,
in Nokia phones. And then I moved to France, joined ST Microelectronics 2007, where I established mobile platform business unit. That was a nice time also because I had a more diversity in customers, not only one internal customer, but then, all the mobile makers of the world. Again, many industrial first things. So for example, our team did the very first multiprocessor for mobile. So
oh wow.
now it's obviously very hygiene, but we did the very first dual core, symmetric dual core processor. And then while being almost 20 years in corporates, I was thinking maybe something more dangerous. And then when we moved back to Finland, I searched for some startups where I could make some impact. And then I crossed to this Wirepas, which was recent spin-off from the local university. And I really liked what they had been researched in the university for a decade. Mesh networks has been under long, let's say, research for decades, but this particular one had a little bit of its own mission, which was that, hey, if the IoT is one day really true, there will be millions and billions of stuff connected. How on earth you can have enough spectrum? How on earth you can have mobility, low power, and so forth? And that led to this innovation that we are taking further, which is fully decentralized wireless network architecture. So from there, we have built a company to have this offering as a software licensing model. We are also doing in some businesses a service model where we even guarantee the performance in the field. But the licensing is a main approach. And it's an ecosystem play. So we are a software company. We team up with radio manufacturers, but also device OEMs and also service providers around the world, depending on which applications we are with.
Fascinating. And fast forward, you have a big focus on electrification and smart grids, among other applications. But why is that such an important focus of yours, and why does IoT connectivity matter so much?
Yeah, so it's in the tremendous change, and this whole electrification is coming in a big wave. So if you look like when we used to have more fuel, actually fuel was decentralized. When you had the peaks of consumption, it was easy to organize because you had a tank next to you. And then electrification started, and you had a grid that was more centralized. But that was a one way, from the production to consumption. And nowadays it's like a little bit of a mix. So it's more decentralized. You have more local production. You have solar panels. You have different types of generation. So you need to have a more two-way approach. And where then connectivity comes into the play is that you need a lot more data points. Data points to build the visibility for the right analysis, decisions, and in the end of the day, resilience. So there's two main objectives with providing a good connectivity to smart grids. One is this kind of an overall visibility buildup. so that the resilience can be built. Um, but also it's really enabling new way of dimensioning the systems. So you can imagine that if you sum up all the peak consumptions in that type of a grid, and if you dimension it that way, it would become super costly. So all these data points, all these kind of a demand, production control and so forth enables then make optimized investments in the grid, but also build the resilience.
Amazing. And as you know from your journey from 1G to 5G and beyond, there's so many options for connectivity. I actually started in paging, so that was like kids don't know what that is, but it's one way communications. But yeah, you have LoRa and all kinds of standards. But why is mesh connectivity, your technology, great for the backbone of a modern digital energy infrastructure?
Yeah, it comes really from the science, I mean, and the physics. Output power needed for a radio to operate is square to the distance. So that's a very simple law. And if you can organize a network so that actually the device participating to the network becomes kind of a base station of its own automatically by software, then you build a coverage that is kind of a superior compared to any centralized system like cellular or LoRa gateway and so forth. And smart metering and grid is a great place to be with that type of architecture. So, for example, we are in India now. India is 250, 300 million metering points.
Wow.
And if you look the country, it has like 500,000 cellular base stations, which is a lot. But still, they leave, black holes and, uncovered places and basements and, there are meters in metal cabinets and so forth. But if you consider that if that whole 300 million would be connected with our type of architecture, you would have 300 million base stations because every meter is a base station. And that gives you the idea how it's so superior as an architecture.
That's fascinating. Let's talk about the architecture. How would you describe the architecture? I mean, we're envisioning what a mesh is. We're all technologists here, but what is the architecture? How does it work, and what does it look like end to end?
Yeah. So first of all, one very important aspect of it is that it's truly from the low level up, fully decentralized. What it means is that all the decisions in the network are done locally by the devices who are participating. So they know the environment the best. So they are in the best position to choose the channel they operate, to choose the output power, to just reach the next neighbor, not needing to shout far off and then, creating interference. So that's one thing. The second thing is that it's completely autonomous. So there's no single point of failure, truly. I mean, if you take a meter away or whatever device away from the network, it doesn't make it any worse as long as there are, enough other devices that picks it up. And the full autonomy also means that the environment is always changing. There's very different weather conditions, seasonalities. The buildings are building up. Cities are building up. There's a traffic, a lot of dynamic situations in the environment. And when the network is completely autonomous, it takes care of itself. Because in this type of massive scale networks where we are talking about millions of devices in one network, if you need to ask the devices, how are you? Can I help you to configure your better? Already that would, take the capacity. So decentralized autonomous operation is really a key.
Amazing. So, we just figure out over the last decade how to scale, millions of devices on 4G and 5G networks from a centralized standpoint, and the networks are pretty good. So you must have other challenges that show up with your technology when you scaled it to tens of millions of devices. What kind of challenges do you have?
Yeah, I mean, like nothing that works on paper works out of the box in all the situations. You need to have a lot of field expertise. And we are lucky because we started as a stack IP licensor. And what does it meant for us was that we were, and we are still in probably in 100 different use cases, ranging from buildings, smart lighting, emergency lighting, to logistics, connecting containers, smart pallets, then smart metering. What does it mean is that there's probably no use case now that we wouldn't somehow be in there in a way or another, understanding what it means to then deploy it. So that's super important. But it's also, like I said, it's continuous innovation. So I give you an example. Mesh networks has also handicaps. If you don't have the range, the proximity between the devices, the connections are not building up. But you need to have different options for the radio physical layer. So in one extreme, we can use cellular-like physical layer, which is ranging kilometers line of sight between the devices. Then we have other extreme where we can use as simple as like Bluetooth chips, which are very low power, but range only a few tens of meters, but they are super affordable. So that's what IoT is a lot about. It's not like one size fits all. You need to have a little bit of ability to adapt and configure it for the purpose, and then learn the use case and take it forward. The other handicap of mesh has been the gateway structures, because you need to have a takeaway points. Although so every device is a router, still you need to have a few gateways here and there that connects it to the rest of the internet. What we did, for example, in smart metering was that we took that whole concept of gateway away as a device, but we put it in some of the meters. So some of the meters with the ratio to like 1 to 300, for example, has capability of cellular connection for the backhaul. And then the deployment is super simple. You just deploy meters, they look all the same, but some of them have a backhaul support, but the rest is meshing, and you don't need to configure anything. So when you achieve that type of innovations, the TCO likes. It starts from easy deployment, easy to maintain because it's autonomous, and then there's no sunset. Nobody comes to shut down the network like in cellular, because it's run by the device itself, and it's owned by the utility, for example, in this case.
Yeah, the economics are completely different. And speaking of that, everything in wireless, as you know, is a sort of three-dimensional trade-off. You have price, performance, you have cost, battery life. They all interplay. How does mesh network change that equation? I mean, what sort of, I wouldn't say endpoint, but what sort of devices can you get with what kind of battery life or maybe performance?
That's a really good question, because people often look only the end device economics. That what's the cost of the radio? What's the battery size I need here, and so forth. But when you look the whole system, and if you look, for example, cellular, of course, cellular is based on very, very heavy infrastructure, which is great. I mean, we both love it. I mean, it's second to none. But in some cases, the subscription fees are just too high. And that's monthly fees. Like if you are a smart light point, you don't want to be paying every month a fee. So it's in mesh, in our mesh, which is, by the way, part of the 5G standards now. It goes with the name NR+. So the more official name is TEC 2020 NR. The beauty of that is that basically the devices participating in the network carry that piece of infrastructure, because they are access points to each other. So you don't need to have that service of macro base stations or even smaller ones. Of course, the gateways here and there, but that's more like a takeaway point to the rest of the internet. So those are important aspects when you look the total cost of ownership, how the whole architecture builds up, what are the Opex elements, how much you need to run cost, month to month, and then you start to see that actually mesh is very competitive. Then I'm proud to say that we are just now announcing. I think it's not even out yet, but I can share it here that we are announcing a world record what comes to what mesh router can be in terms of power consumption.
Wow.
We are releasing with our close partner Nordic Semiconductor new chipset NRF54L. Together with that low power features and our very low power mesh architecture, we can have a router in a mesh network that consumes in the range of 20 microamps.
Wow.
That means that you can have a multi-year autonomy with a single commodity battery. And again, normally mesh networks are mains powered what comes to routers. So this is unique.
Really unique, and so many opportunities. You kind of touched on a couple in India, but care to share any more examples of performance in these dense, interference-heavy environments?
Yeah, and I would like to maybe still continue India a little bit because it is really extreme. I mean, we haven't seen such scale anywhere else. We actually did in Europe already before a network which was 1 million. 1 million as a one network connecting the city of Oslo for smart metering. But now we are breaking that record many times in India. The biggest utilities are having 30 million meters as a single utility. So they are very big. And so that scale is one. So in our network, it works with N, it works with N. There's no limit. And we have gone beyond 1 million. So it's really proven. The second thing is that actually India gives you the highest densities too. For example, slum area, there's a meter every 5 meters. and when you have a long range radio, you are talking relatively very high density. And if you cannot cope it, and if you are not having very, very high spectrum efficiency, the network collapse if you don't scope it. So that is a very bad surprise at that point when you are almost done. So that's a super important. We are very good in spectrum efficiency. And then it's really the different terrains. I mean, it's ranged from high dense downtown, but also rural areas and anything between. So those are the good examples. But we do have also other examples where we are solving problems that others are not. Like, for example, in container business, the biggest vessels in the world can carry something like 20,000 containers. They are side by side, big metallic giants. No other radio can survive in that environment because there's so many, reflections, multipath, propagations, and so forth. And we have proven it. So that's really the power of this decentralized local decision-making capability networks that survive almost anywhere.
Incredible. So this year, resilience has been a big topic, whether you're an impact of a storm or, in the US, a hurricane or earthquake or other natural calamity, or in Ukraine, not so natural calamities. The energy is going to have to be rebuilt one day. I imagine that's a big part of your solution is building resilience into the network.
Absolutely. I mean, of course, I give all the credits and merits to the guys who are building the grid itself. I mean, it's amazing work what the world leaders are doing there. But what we bring to the mix is ability to have these data point collections in reliable and highly resilient way. You mentioned many good examples. One more is what happened in Iberia, Spain, Portugal last spring. The whole nation was down because of the blackout.
Right.
So total outage. And by the way, in India, in some areas, you can have like 10 outages during the day.
Wow.
And what helps to fix those is really connectivity, because again, connectivity provides data gives you visibility, and then you start to see where the leakages are, where the problems are, and you go and fix, and you get towards 99.9 eventually in all the metrics. So that's our mission. We want to be facilitating and enabling and helping on this massive electrification that is ongoing around the world.
Fascinating. Maybe talk about your go-to-market on the commercial side. I assume I can't go to your website and just buy a bunch of radios, or can I? How do you go to market and with whom?
Yeah, so we are B2B business.
Hmm.
So it's really the go-to-market is first of all go with the ecosystem partners. So we have radio partners and some design partners, and then you find the right service providers in different businesses. That's typically our go-to-market. So, for example, smart metering, there are specialized service providers who really are tackling that utility business, and they are collecting the team, if you like, for every opportunity, and then we are part of that, and we are helping to integrate the meter with the connectivity, the head-end system that is part of that architecture, and so forth. Similarly, if you go, for example, hospitals, where we are having service providers that are providing location services. So they put sensors to the wheelchairs, beds, whatever assets the hospital is having, and then we together help to make the guides how you install those systems without interrupting the operations. That's really, really powerful in our technology, that the deployment is super easy. And that's what IoT projects very often overlook. They focus on end device cost and they focus on many other things, but deployment, that's really costly if it's not efficient. So service providers, in short, is our go-to market. And then, of course, we choose our segments where we double down more, because where you have the value, where you have the fit, then you grow there. But like I said, we have great number of use cases also beyond those examples.
Fantastic. So you're at the cutting edge now. Amazing. But where do you see yourself going over the next year or two? What's exciting in terms of roadmap or new opportunities out there?
Yeah, so maybe kind of got quickly back where I started. So about the Wirepas. So what I'm very proud of our team is that we are really a research organization too. So we are in the frontier of this part of the wireless story. And what it means is that we research, we contribute to the standard. So this Tech 2020 NR, which is in ETSI, European Telecommunication Standard Institute. So there's a specific group where we are the biggest contributor of that standard. And with that, we kind of give it to open. So we are wireless veterans as a team. We are holding more than 500 patents in the team. There are people who have a background from cellular, from Bluetooth, from Wi-Fi, and so forth. So we know that to be able to scale is an ecosystem open play. So that's one important part. But now when we see this market moving to especially electrification, you cannot scope anymore with centralized connectivity architectures like cellular. You just cannot build the scale. You cannot go to the difficult places. Also, there's another technology which has been dominant in some countries called power line communication, which is using wires. But that also gets the limits. So, for example, in Finland, we are now 5-minute reading in the wall. As a consumer, I can see my consumption 5 minutes in the wall. And my tariff is every 15 minutes changing. So guess where this is going? This is going, more and more frequent reading. And with NR Plus, we can already demonstrate sub-second reading intervals on the grid side. And that's where I see where we are going. So the whole world is electrification. Other areas are developing the direction that you really need those data points in an efficient manner, and then that really explodes the platformization for the AI on top of it, which is happening in parallel. But AI is as good as the data in. Garbage in, garbage out. We try to avoid that. So therefore, I see that the symbiotic play between kind of embedded AI, physical AI, our connectivity, which is decentralized, have a very interesting intersection point, and the volumes will be massive.
Amazing. Well, what an opportunity. Thanks so much for sharing the vision and mission, and good luck along the journey. Thanks, Teppo.
Thanks, Crystal. It was a pleasure to be here. Thanks for having me today.
Thanks, and thanks everyone for listening, watching, sharing this episode. Also, check out the TV show, TechImpact.tv on Bloomberg and Fox Business, and see everyone at CES. Hopefully, there'll be a lot of IoT innovation on display there as well. Thanks, everyone.